A formula in mathematics is an equation that involves more than one variable. I've written some fairly common formulas over here on the board. A equals L times W, that's the formula for the area of a rectangle. P equals 2L plus 2W, that's the formula for the perimeter of a rectangle. F equals 9/5 C plus 32, that's the formula that gives the relationship between the two different temperature scales, Fahrenheit and Celsius. Y equals mx plus b. This turns out to be an important formula in mathematics. It's the formula for the equation of a line with a slope of m and a y-intercept of b. E equals 8 LWH is the formula for the energy in an ocean wave. And z equals x minus, this is the Greek letter mu, over s, is the formula for a z-score in statistics. There's many, many formulas in mathematics. What links them all together is that they're equations that involve more than one variable. Let's see some of the problems that we can work involving formulas. Suppose that G is equal to H times R, and we want to find G if H is equal to 36 hours and R is equal to $8 per hour. So this formula right here is the formula for gross pay if you work H hours per week at a rate of R dollars per hour. So I know that H is 36, R is equal to 8, and G is equal to H times R. So G will be equal to H, which is 36, times 8 times R, which is 8, and that comes out to be, let's see if I multiply 8 times 6 is 48, carry the 4, 8 times 3 is 24, and 4 is 28, 288. So this will be $288. That will be the gross pay that you will make if you work 36 hours a week at a rate of $8 per hour. Now that's something that you already know, but all we did is put it in the form of a formula. Let's do the same problem again, but with H equal to 20 hours and R equal to 6 3/4 per hour. So this time, what we're going to have is that G will be equal to H times R. Since H is equal to 20 and R is equal to 6 3/4, I'll have 20 times 6 3/4. 20 times 6 3/4, 20 times 6, 180. 20 times, whoops, what did I say? 2 times 6 is 12, 120. And then 20 times 3/4, 4 divides into 25 times 3 is 15. So this comes out to be 135. Now there's other ways to do that arithmetic right there. I just did kind of a shortcut thinking that 6 3/4 is 6 plus 3/4, and I used the distributive property. 20 times 6 is 120, 20 times 3/4 is 15, and so 20 plus 15 is 135. So again, we simply use this formula right here, G equal H times R, to find G when we were given H and R. Let's look at that formula that compares the two temperature systems. We have C is equal to 5/9 times the quantity F minus 32, a little different version of the formula that we showed right in the beginning of this lesson. Now, we want to find C if F is equal to 158. So I'm simply going to take 158, replace F with that, and then calculate what C is. So C is equal to 5/9 times 158 minus 32. So let's see, 158 minus 32, this will be 5/9 times 2 from 8 is 6, 3 from 5 is 2, so I have 126. Let's see, does 9 divide in there evenly? I hope so. This is going to be 5 times, 9 divides into 12, let's see, once, and then I have 3 left over, 4. So 5 times 4 is 20, carry the 2, 5, 6, 7. So I end up with 70. So a temperature of 158 degrees Fahrenheit is equivalent to a temperature of 70 degrees Celsius. So I didn't put the little units on here, degrees C and degrees F, but they're there if we need them. So if F is 158, I substitute it back in here, do this arithmetic, and what comes out is 70. So 70 is the Celsius temperature that corresponds to a Fahrenheit temperature of 158 degrees. Let's try one more. What if F is 32? 32 degrees Fahrenheit is freezing. That's the temperature at which water freezes. Let's see what C is. C is equal to 5/9 F minus 32. So I take 32 and substitute it in for F. That gives me C equal 5/9 times 32 minus 32. That will be 5/9 times 0, which will be 0. So a Fahrenheit temperature of 32 degrees corresponds to a Celsius temperature of 0 degrees, and that's true. Water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. Let's look at a problem that involves the area of a circle. A is equal to pi r squared. Find A if pi is 22/7 and r is equal to 7 feet. So A is equal to pi r squared. Pi is 22/7, so I'll substitute that in. R is equal to 7, I'll substitute that in, and I end up with A is equal to 22/7 times 7 feet squared. So I'll have 22 divided by 7 times 7 times 7, because that's 7 squared, feet squared. Now let's see, those 7's divide out. So I'll multiply 22 just times 7 right there. 7 times 2 is 14. Carry the 1, 14 and 1 is 15. 154 square feet. So this gives us the area of a circle that has a radius of 7 feet if we use this approximation for pi of 22/7. So notice that when my units involve feet right here and then they're squared in the formula, that the units are squared also. So I start with feet and I end up with square feet. Let's try another one. R is equal to 3/4 of a foot. Pi is equal to 22/7. And the area is equal to pi r squared. So I'll substitute both these values, both this value and this value, into this formula, and I end up with A is equal to 22/7 times 3/4 squared, and then I'll just put my feet squared on the outside. So 22/7 times, let's see, 3 squared is 9/16. And what have I got here? A common factor of 2, so that's 11, and 8 divides in there. Anything else? No. So 11 times 9 is 99, and then 8 times 7 is 56. So 99/56 square feet, and I could change that if I wanted to into an improper fraction also, but I think I'll just leave it right there. So if pi is equal to 22/7 and my radius is 3/4 of a foot, then I end up with an area of 99/56 square feet.